Good.
So, welcome everybody. This is the November meeting of the Tucson Astronomy Association's Astronomy Fundamentals Group. Tonight we have two presentations lined up as our usual cadence. We took a break last month for the annular solar eclipse, and we'll probably talk about more of that here after the main topic. Right now we just kind of want to quickly go ahead and get started with our main topic tonight, which is by Jim Knoll, Bob Rose, and Gary Steffens. Thank you, Bob. Who are going to be giving a walkthrough of the Meade Hand Controller system on this 12-inch Meade that's in front of us on the webcam. I'm going to go ahead and need to spotlight Bob so that his camera stays there. And then after this hand controller walkthrough, Pete Hermes will be giving our astronomer of the month on Gregory Hale. And
George Ellery Hale.
George Ellery Hale. George and Gregory, they look very similar to me, and my brain is stuck on grad school and trying to survive that last month of the semester. So I'm making a lot of slips of the tongue, and I apologize. So Jim, Bob, and Gary, we will turn it over to you, and you can get started whenever you're ready.
Okay. Excellent. So this is this is Jim Knoll. We're out of CAC. So if you haven't made it out to CAC, you should come out sometime and check it out. It's a really great facility. What we've got out here is quite a few different telescopes. We've got the 40-inch big boy, the 9-inch folded refractor, 14-inch Celestron 14-inch, and we're going to show you the Meade 12-inch tonight. We've got a Celestron 11 and 9 1/4 and all kinds of good stuff out here. So we're going to have a nice group. This is a typical CAC weekend, similar to what we do at Tampa. And the weather right now is pretty good. So what we're going to do is we're going to walk through the Meade 12-inch LX200 that we have out here in the stinger pad. It's mounted on a permanent pier, polar wedge. And we'll walk through a little bit of the hand controller and then answer any questions. So Bob, if you want to kind of slew it over here, and we'll get the light on there and make sure everybody can see the hand controller.
I think they can probably see it better without the light on the hand controller.
Yeah, maybe
turn it around a little bit away a little bit more.
So is that good for everybody?
Can y'all read it?
All right. So when we first fired it up, this is kind of what it came up. It came up and did the GPS alignment to make sure it knew where it was. This thing would be already polar aligned. I'll show you where you can put it into a park position. And so that, if you have something permanently mounted, you want to be able to not have to go through an alignment every time. So when it comes up, it's going to get you all ready to do some observing. So the first menu item is an object. And so in here, what you can do is when you're on something, you can just hit the enter button. And in this case, it will.
Can y'all see where the enter button is, where he's pointing his finger?
Yes. The buttons are lighting up well, so.
Yeah. Okay. All right. So when I hit enter, it brought us to the solar system. And then down at the bottom, down here, you can see an up and down arrow.
We just lost the focus.
Just back it off a little.
You're good.
How's that?
That right there is good.
All right. So you got an up and down button right here that you can cycle through stuff. So if you look up at the top, you can see it's on solar system. So if we hit enter again, come on, baby. And now it's on like Mercury, so you can cycle through and go to Venus, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, the moon, and then you can do asteroids, comets, and then you're back to Mercury. So that's how you would cycle through. So for instance, if you wanted to take the scope to Jupiter, now if you hit enter here, it's going to give you some information about Jupiter. It's going to tell you what the RA and deck is. I think it's what it's showing there.
Mm-hmm. Hey,
and then if I were to hit
move the hand controller up right there. Right there.
More I'll try to hold it steady. So if I were to hit go to right now, the telescope would actually slew to Jupiter. We won't do that because we want to kind of go through all the menu options, and then we'll come back and do a last slew. So then if you
Jim, I got a question.
What about comets? Let's say comets, is that something that's kept up to date? Or what's the
Not
deal there?
generally, yeah, not generally in hand paddles. Now, if you connect up your scope to Sky Safari or some other
Right.
planetarium program, then yes. But off the hand paddle, it's typically asteroids is about the most dynamic you're going to get.
Really? Okay.
Yep. All right. So when we're done, so if we don't want to do Jupiter, you hit the mode button once, and that takes you back to where the solar system. You hit mode again, and takes you one level up. So mode just keeps going back, and now we're back to object again. So if we go on to object, and now if we wanted to do something other than the solar system, you can do constellations, and it'll point to a general constellation area. You can do deep sky. We'll come back to that one here in a minute. Stars, satellites. If you have any user saved objects, you can do that. Landmarks, I'm not sure exactly what that does for you. Identify, you can browse, and then you're back to solar system again. So those are, you just kind of, it's the menu system. As you go deeper and deeper into the menu by hitting enter, will walk you through stuff. And then if you want to go back, you just continually hit the mode button until you get back to the level you want. You guys jump in anytime if you need to.
Doing good.
All right, so that's the solar system. So there's constellations. Here's deep sky. If we hit enter on deep sky, then you can do named objects, galaxies, nebulas, planetaries, star clusters, quasars, black holes, Abel, ARP, MCG, UGC, Herschel. Eventually we'll get to NGC, there you go, and Messier. Well, maybe not. There's Messier. And so that you would just cycle through that. And then again, if you hit enter, you can put in a number. So if you wanted to do like Andromeda, you could put in 031 or 31 and then hit enter and go to, and it would take you to that particular object. So let's go back. So that's the deep sky. And you just kind of walk through. You can do stars, satellites, and things like that. So that is all of the different object ones. So that's going to be your main source that you want to do when you're doing observing.
In the constellation menu, you can actually sub-menu that into the stars, the main stars in the constellation.
Okay, so you can
like
dive down into
Lyra or whatever.
Oh, okay.
Yeah.
I've never used it. So.
Yeah. So there's lots of capability on these guys.
I would add that if you aren't familiar with any of those catalogs, if you are a first-time user of the scope, you can actually the identify menu that they showed earlier would be a very useful tool for you. So you can actually just take your scope and point it around to anything in the night sky, just on your own by using the 4 arrow direction buttons. And then you can use the identified menu if you find something of interest, like say a star cluster, and the identified menu will oftentimes tell you what that object is. So you can, if you don't have any of these catalogs well memorized or written down as you start an observing session.
Yeah, and that's actually a good point. We didn't really talk about the actual hand paddle and all the buttons on here. So up here at the top, you've got the enter, the mode, and the go to, which we've been dealing with. Then you've got the 4 arrows, and that's what Connor was talking about, where you can manually slew the telescope any direction you want. And then you can change the speed right here. And then there are some of the catalogs that are hot buttons here. So there's the Caldwell, Messier, stars, solar system, UGC, I think that is, and NGC. So you can go directly. If you hit like NGC here, it's going to take you right to the NGCs, and you just type in the number, whatever you want, you hit go to, and away it goes. So there are some shortcuts there that you can do.
One other general hand wave disclaimer here is, like all manufacturers, the hand controller layouts will change depending on the age of your scope. So there may be some buttons on here that you don't see on your hand controller. That's normal, but the menu structure itself should be quite similar.
Yeah, the Meade I've got at home is an LX200 Classic, and it's probably about 25 years old, and it doesn't have the raised buttons. It's got just pads that you push, so it's totally different than this. But the functionality of some of the stuff you can do is all the same. All right, so we'll go back up to get back to objects. So that's how you work through the objects. Event, I'm not real sure what an event does. Maybe if
Like
there's
looking for meteor showers, things
something like that. So if there's a certain event going on that are scheduled, that are routine, you can use event for that. You can do a guided tour. Most hand paddles do that, so you can just let the computer make recommendations. It should only recommend stuff that's up based on your time and location, but you may have to evaluate that a little bit. So there's the guided tour. Glossary if you want to look up something if you're not sure what it is. Utilities, we'll come back to that one here in a minute. Setup, we'll come back in just a minute, and then we're back to object. So let's go up to utilities. And if we enter there, so now you can, if you want to do the ambient temperature and enter it, you can.
It'll tell you what the hand paddle
It'll tell
is.
you what it is.
Yeah. Oh, okay. It tells you what the temperature of the hand paddle is.
Actually, at the telescope itself.
Oh,
That
okay.
one's sensors in it. Mine's
Yeah.
mine's in the hand pad.
Was it really?
Oh,
What
Yeah,
what is
my-
the temperature? What does setting that actually do for you?
It doesn't. It's not. It just tells you what the temperature is. Push it. Push enter.
Oh, so it's just informational.
yeah.
Okay,
It is a little chilly here.
that's not
So
bad.
it's 49 degrees. All right, so let's go back to utilities. Let's see, enter there. So yeah, ambient temperature. There's a timer function. I guess you could set it up to
It'll beep at you.
yeah. If you want to set a certain timer. Same with the alarm.
Yep.
Eyepiece calculation. I guess you can probably put in
Yeah, and it'll tell you the
Field of view.
field of view.
Yeah,
And things like that.
yeah. So it ways to kind of give you an idea of what you're looking at.
Yeah, it knows what type of telescope it is and the focal length, so that's how it takes that into account.
Calculates
Yeah.
Mhm.
everything. Okay. Brightest star. I don't know what that does. Put it on a brightest, I guess.
Must be the brightest star that's visible.
Brightest star on. So yeah, maybe it uses the brighter stars to
The alignment.
alignment stuff and things like that if you have it on.
Whatever you say.
I have either brightness adjustment. I'm not sure there.
That's for the hand.
Yeah, it's for your display.
Oh yeah, that's for the
Display.
there. Yeah. Contrast, same thing for the panel and the screen. You can adjust. Most of the stuff you won't have to do much. Panel light if you want to turn it on or off. Aux port power, same thing. If you want to turn the beep on or off. If you want an alarm for the battery,
Which we don't have.
which we don't have. Landmark survey, I don't know what that does.
I think that's if it's on a pier and you want to align the finder to a specific landmark, you can
okay.
register it as a landmark on the horizon
Okay.
and it'll go to it. And then you can align your finder scope to the main scope.
Okay. You can sleep the scope, so that basically just leaves it right in that position, but it shuts everything down. So if you don't want to park it or something like that, you can just put it to sleep. And then in part of this utilities is the park scope. So most of the scopes have a designated park position, but I think you can set up what it is. You could have like park 1 and tell it what position what you want it to be in, and different park positions. And what the park does for you is, for instance, with this scope, since it's permanently mounted, what we will do is when the user is done with it, they will park it and then shut it off, and it should remember all the alignment stuff, and you don't have to go back through another alignment process. If you wake it up accordingly, it'll wake right up, and you should be able to go right to your first object. So parking a scope is really nice if you're leaving it in a location. When I'm up at the Grand Canyon Star Party with my C11, what I do, it's on a tripod, but what I do is first night I do a good alignment, and then subsequent nights I just park it and I just put it to sleep, put a cover over it. And then the next night, even if it's not dark, I can wake it up and look at daytime planets or something like that before it even gets dark. And you can get started a lot faster than a lot of other people, and you don't have to go through the alignment process. So parking a scope is a really cool feature. And then we're back to ambient temperature. So if we go up a level from utilities, you go down to the setup. And in the setup, here's where you would align the scope. And so if you want to go into alignment, and each one's going to be a little bit different, I mean, we can at least go into it. You can do an easy alignment, 1-star, 2-star alignment, align on home, and back to easy. So there's different alignment processes you can do.
So one quick interruption here is if you're a person who moves around your scope frequently, doesn't have an park position, normally once you turn the hand controller on, it will ask you to align the scope. The submenu here is usually to help readjust the alignment later on in the evening after that initial alignment. If you start noticing that things aren't lining up during your session, which is a normal occurrence to sometimes have to do if you're observing over the whole night.
Yeah. Yep. Anything else on the alignment? No.
You can also just point the telescope at a known object and sync on it, and they'll align it as well, since it's permanently mounted.
Yeah. So and the more times you do that, the better the alignment process probably is. As you do, if you go to the subsequent star and it's off a little bit, you sync on it, and it's going to get a little bit better.
Yeah.
Now, if it's your personal scope or you're setting it up each time, you'll have to go through the alignment procedure every time you set the scope up.
Right.
Because they have no idea where it's at.
Right. Yep. All right. So let's go up one. Come on, baby. And then there's polar align, which is what we would use here since we have it on a wedge. And so if you're doing a polar alignment, you can work through that.
Yeah, it's reading the instructions.
Yeah.
So similar to what I showed or talked through when I did the celestial head controller, the way the polar alignment works is it'll slew the telescope to a star. You will center your eyepiece or your camera on that star, and then the scope will slew again, and then you will manually adjust the scope to get that star you found earlier back into your field of view as a means to better polar align your scope. Without the need for doing something like plate solving or having a polar axis scope, which you can't really have on a wedge, but some other scopes will have a polar axis scope that would help aid that process.
Yeah. Okay. So still in the setup menu, you've got the date where you can set the date, you can set the time. If you don't have a GPS built in, you can do all that. Whether or not you're using daylight savings time, which would be no for us here. And then you can do a GPS for the GPS. You can do a UTC offset. So here, for instance, we're -7. So you would put that in, and that would help the GPS better define where you're at. And then you can set up telescope. Let's see what's in here.
That'll be the type.
Yeah, you can describe the mount you're on, the model, focal length, all that. So again, if it's a new scope or something like that, you may have to go through and do some of those kinds of setups.
Yeah, the mount will be alt-az or polar.
Right.
Depending on how you have it mounted.
You can do a park position. So I think that's probably where you can define what the park position is. Calibrate. You can change a backlash. So when it's slewing, whether it has an anti-backlash function. Train the drive. So, I mean, a lot of this stuff you'll never use or change in the telescope, but it's there. You can change how fast it guides. You can reverse left and right. So if it flips things around and you get confused because you push the left button and it goes to the right, then you can change it in here so it doesn't affect it. Or same with up down. Home sensors, GPS alignment, RA and deck.
That's for changing the pack.
Yeah. So this is a lot of this kind of stuff you just really don't need to do too much with. But
the high precision you just passed, it allows you to go to a known object and you can center on that, and then it goes to the object you're interested in. It'll be right in the eyepiece.
Oh, okay.
You'll go to using a bright star.
Yeah,
that's
right.
You usually pick a bright star.
I'm not familiar with a lot of this stuff. If you guys want to talk through,
the mount is whether it's alt-az or
right
or polar mount.
So if you hit enter here, you do tell it
This one
whether
better be
it's,
polar.
yeah, polar,
Yeah.
Altaz, or polar. Yep. So we won't change that. Telescope model, focal length. So we're back again. So let's go level. So that's set up with the telescope, and I think that was. Oops, wait a minute. Not sure what the targets does.
Targets
Oh, I guess
may
if you.
be allowing you to add additional items to the catalog. Probably is like you do a firmware update and you can get more. I guess.
Yeah, and it looks like you can do terrestrial, so you can put in some terrestrial targets or astronomical. Yeah, so yeah, different things you can set up.
Shouldn't that thing be on astronomical?
Yeah, I think we went on this.
Yeah, put it back on astronomical. There you go. Select.
Okay.
Yeah.
Let's just make sure we
The
are.
motors won't
there.
run without it.
No, they get fussy.
Okay, we're on astronomical. All right,
Yep, that's what we want.
we'll stay there. Site, you can specify the site location if you need to, coordinates.
So, real
Or-
quick, there was a quick question in the chat by, and it was kind of answered, but I just wanted to voice this for the recording. Sharon had asked what you meant by we are -7 here. So when you are aligning your scope, it needs to know what time is for you locally so that it can accurately point to things in the night sky. So when you'll often see is UTC -7. So that just means that you are 7 hours behind what is defined as Greenwich Mean Time. So for US folks, depending on if you're East Coast, it'll be UTC -4 or UTC -5, depending on daylight savings time or not. For those on the Pacific Coast, it would be UTC -8 or UTC -7, again, depending on daylight savings time. Conveniently for us here in Arizona, there's no daylight savings time, so it's always UTC -7 for us.
Saw another question pop up, but I didn't
Yeah,
catch it.
I'm reading it. So there is, Robert says he has a star sense that is supposed to automatically align my scope. Does he need to put the current location and time, or is that automatic? I believe you would still have to enter that unless your scope has a GPS in it.
Yeah.
If it has a GPS in it, it will often use that for both time and location because the GPS will also encode time. But if you do not have a GPS, you would likely have to enter that on startup.
And it does have a GPS, so that's
Yeah, so that's good. All right, let's see. Talking about the mount, owner information if you want to put it in. Clone, I don't know why we want to clone it, download, yeah. Statistics, reset if you want to, we don't want to do
No,
that.
don't do that.
And align, so back there. So let me go up a level. And I think that is most everything. Let me scroll through and see if there's, yeah, we're back to object. So that's pretty much everything. You guys want to add in anything else that?
So I mentioned syncing on the object. If you want to get your telescope to align proper or to a little more accurate. So for example, if we wanted to go to M31, you push the M button, which is the number 3 button there, then type in 31 and then go to, and if the object's off, you can use those red buttons to manually move it. And then if you hold the enter button down for 5 seconds, it'll say, okay, do you want to sync on it? And you push it one more time to say yes. And now it knows exactly where it's pointing.
So that's a good way to refine the alignment, or if you start drifting after several hours and you need to get it back up again. Yeah. So let's just go to a solar system. We'll flew over to Jupiter, and if you guys want to put the camera on the scope. So right now, hang on a second before you go. So it's Mercury. We'll go down to Venus, Mars. There's Jupiter. So if I hit go to, it's going to start slewing. Put it on the scope.
Okay.
I think you want to hit enter first.
Oh,
Enter.
no, it's okay. Let's go back. I didn't think we needed it. Let's
Get back on Jupiter.
get back to Jupiter.
Yeah, when you push the enter, it actually figures out the coordinates.
Okay, so we'll
Yeah.
do enter. It's calculating, and then if we go to,
Yep.
there she goes. It's actually going over towards Jupiter. Yeah.
That's in Texas. Yeah, that's where that storm is.
All right, and so that's pretty much it. What other questions you got?
Okay, so I have a question. One of the scopes that was donated, and it's sitting in the barn right now, is a Meade ETX 60 something. I took it out to test it some months ago in my backyard, and I did the auto align, which it automatically pointed to 2 stars, and it told me what stars it was pointing to, and it did that fine. And then I put it in the mode to look for a constellation, and it found the first constellation I entered. But then when I entered a second constellation, it started slewing in one direction, didn't slew in the other axis, and then came back with an error message. I tried it again, doing a manual 2-star alignment, and it did exactly the same thing.
Okay, when the error message was like an MUF error or something like that.
You know, I wish I had written it down. I did not, but I'm going to try it again. But for some reason, it was only slewing in one axis when I did the second constellation.
Okay. Yeah, it sounds like you're getting a motor fault.
Oh, great.
You're running off batteries.
Yeah, but I put brand new batteries in it.
Okay.
When
Well,
I did this.
it doesn't matter. If you had last time, if it had old batteries, it learns the batteries. So what you're going to have to do is do what they call a calibrate motor. And it's under the utilities menu. You put the new batteries in and just turn it on, and then go right to the utilities menu, and where it says calibrate motors, just hit that, and it'll take off running fast as it can in both axes.
Can
One
show
at a
that-
time.
Can you show that menu on the head controller since
Oh.
you have it in front of you?
Okay. Yeah, because I didn't get an instruction manual, so I didn't hear
No.
about that.
Yeah, and what it does is those cards that are in there, it will learn how many milliamps it takes to run each motor at a certain speed, and then it will adjust for the batteries. And you'll have to do that again when the batteries start running down, or you'll start getting those MUF errors or
Okay,
motor faults.
I'll try that.
Yes, try that.
Or get a better or AC adapter.
Get an AC adapter. Do it one time, then life is easy.
Can you show that menu on the hand controller since we have that one handy for us?
Okay, let me bring over and see, and it should be.
It's under utilities. Okay.
Yeah. All right.
Of course, the hand controller I got is different than this one, but it has all the same stuff.
Yeah.
Go up further.
No. And then I'm gonna go utilities, and then enter, and then
Okay, can you wait 1 second? I got something popping up on my screen.
yeah, yours is gonna be a little bit
My,
different.
no,
because you've got a
my
497 control.
computer screen popped something up in the foreground. It runs, it's got a background task that's running. Okay, can you let me see that again?
Okay, I'm in the utilities. Oh, you want to go all the way back? Okay.
No, I know how to get to the utilities. Okay, so
Get
I'm
the
in
utilities.
utilities.
And then you just keep scrolling over till you see brightest star, brightest panel lights. It might be under the telescope menu and setup. Maybe that's where I know it might be under the setup.
Okay,
Yeah, it does make more sense. Yeah, it's setup, align, date, time, daylight saving, GPS, telescope. It's probably under this. Enter, mount, telescope model, focal length, maximum slew rate. You can mount user limits, park position, calibrate motor. Oh, that's the
Okay.
home.
that's under
any
telescope. Calibrate motor.
trains, no, that's PEC. Calibrate sensors. On this one, it's called yours will be called calibrate motors.
Okay,
Do you find it on there, or you don't have it
Yeah,
with
I'm not, I don't have the telescope with me. It's out at
you?
the barn.
Yeah,
Uh,
yours will say calibrate motors, not calibrate sensors.
okay, very good. Thank you. I thought
Okay.
I was just about ready to give up on it.
Yeah. Well, don't give up on it. That the hand controller is actually worth more than the telescope.
In this case, yes, it is. That's true.
Yeah.
It's a
Don't you might throw a
little
telescope with it.
60
Keep
millimeter.
your hand controller. These things are like precious right now.
All right, anything else?
I don't see any more questions in the chat. I don't hear any more coming over to the Zoom. So I will call that a no. And thank you, gentlemen, all for putting this on and walking us
Okay.
through.
Thanks, guys. That was great.
All right.
All right, sounds good. Well, we're going to back off and go do some observing, but you guys have a good meeting and we'll talk later.
Good, happy guys.
All right.
Kill us out of that.
Good job. Good job,
Yeah.
guys.
And,
Oh, wow.
and I hope everybody enjoyed the solar eclipse last month and got some good pictures or had some good luck with their weather. And
Yeah, I watched the whole thing from my front yard.
I ended up in the Four Corners zone with a gentleman from Colorado in the middle of a community baseball park on an Indian reservation because Albuquerque's forecast was cloudy. So good weather. Good
I was
pictures.
in Monument Valley. It was beautiful.
And Pete,
Beautiful.
you are a co-host, so you can present whenever you are ready.
Okay, I'll start my share pretty soon, but first I thought I would share my ambient temperature up here in Oro Valley. That's with my controller. I am inside, so it's not 60 degrees. I think my thermostat last I checked was about 71 degrees, so I'm pretty comfortable in here. There's no wind either, and I will not be doing an alignment. However, I will share my screen now. And hopefully you can all see the first slide in my PowerPoint, George Ellery Hale.
Yes.
Anyhow, thank you very much. As usual, it's always a pleasure to present to this august group. Tonight we'll be talking about George Ellery Hale, a very prominent astrophysicist and astronomer, primarily from, we'll call it the late 19th, early 20th century. And we'll talk a little bit about his career, but like probably the two main things he's noted for and very well known for. He was one of the foremost astrophysicists, and during his time when he was working primarily in the late 1800s, early 1900s, and equally as notable, especially with respect to the Yerkes Observatory in Wisconsin and Mount Wilson in California, as far as designing, building, developing, directing. And we'll get into that a little bit later, but then he was also involved in a couple of other telescopes and observatories. But that was his big thing. It's kind of interesting. I don't know a lot about a lot of astronomers. I know a lot of them have built some of their own equipment, but these were major projects. I think, trying to remember, I think Stephen might have talked about some of these telescopes and observatories in a past presentation. We'll touch on those a little bit. I'm not going to get so much into the observatories. We will cover them because most notably, these were a significant part of his career. And so anyhow, we'll talk about career highlights. I'll move back and forth. This isn't going to be a chronological presentation. I apologize if it gets a little confusing, but if something's a little off kilter, just yell at me, hey Pete, and we'll stop and we'll clear it up. But I'll talk about his career highlights. We'll get a little bit into his personal life, starting out, education, some of his work, some of his legacy, and of course, a few references at the end. There is one, hopefully remind me to talk about one of those references if I forget, because it's sort of a nice compendium basically on his entire life. And it was a memoir that was presented at the National Academy of Sciences fall meeting in 1939. That's really quite interesting. And of course, one of the sources that I used. for this presentation. But as far as the career highlights, and I've got a few pictures here. As far as research and the type of work he did, Hale was primarily interested in the sun, stellar evolution to some degree, but primarily the sun. He discovered quite a few things about sunspots, the corona, and various parts of our own sun, and spent a lot of time researching the sun and developed a lot of techniques and did some, groundbreaking work in some of these areas, much recognized, published. There's his notes and research, are maintained in libraries. So there's an extensive record of all the work he did, and he did a lot of work. But anyhow, as far as planning and construction of telescopes, the 40-inch refractor at Yerkes Observatory in Williams Bay, Wisconsin, which I suspect is just across the border, because a lot of this was associated with his work at the University of Chicago. Shortly after, that was probably one of his first big jobs, and I'll talk a little bit more about that. The 60-inch Hale reflecting telescope at Mount Wilson. Mount Wilson basically was something that he and a few people started. There was a lot of his heart and soul, I guess is the best way to put it, I think, into Mount Wilson. The 100-inch Hooker reflecting telescope eventually came to be placed at Mount Wilson. And then I'm not sure about this as far as the 200-inch Hale reflecting at Palomar, how much involvement he had with this particular observatory and or telescope, because like I say, he had involvement both with the observatories themselves, the grounds, the infrastructure, and the telescopes. I do know for a fact, as far as Yerkes and Mount Wilson, he had a significant part of designing and saying how those observatories and telescopes were built. He was also known later on in his career. Hale was a pretty affable individual. One of the things he cherished in his work was the opportunity to talk to other physicists, astrophysicists, astronomers, both in the United States and over to Europe. He used to go over there occasionally and interface with those, but that was one of his big things. Much like I talked, I presented on Eddington back in July. Eddington was probably about 15, 18 years offset, a little bit later. I'm sure there's probably some point at which they would have intersected, because Eddington was very much working on stellar research. So I would suspect that they probably might have conversed, might have at least communicated during their careers. But the other thing, like I say, Hale was very much interested in the collegial aspects of his field. And one of the things, he was very instrumental in a number of organizations. And one of the things he helped found was the International Union for Cooperation in Solar Research as part of the National Research Council. And then probably one of the more significant things towards the end of his life, he, along with a couple of other key individuals, were founding members in developing the California Institute of Technology, Caltech, probably with respect to astrophysics, astronomy, one of the 3 or 4 key institutions in this country and to a large extent in the world as far as the reputation and recognition, especially when it comes to space sciences, astronomy, physics, and a lot of other areas too. I won't just limit it to that, but at least as far as our particular interest in the field. Okay, backtracking a little bit about his life. He was born June 29th, 1868 in Chicago, Illinois. I think the family spent a lot of time, I don't know if he was born at the time, but they had a house down in what was called the Kenwood district of Chicago, which was basically along the lake shore, Lake Michigan. In South Chicago, streets ran east-west in Chicago. So if you had 31st Street and you were down in South Chicago, you're 31 blocks of the central part. But basically, Kenwood ran from about 31st down to 54th Street and probably ran a couple of miles in from the lake shore. At that point, the lake shore is sort of curving back down to the southeast. But, and of course, back then it was probably significantly different than what it is now. But he was the oldest of 3 children that made it into later life. His parents, William Ellery Hale and Mary Brown. William Ellery Hale, there's a fairly good family record dating from the time when the Hales immigrated from England back in the I think the early parts of the 17th century, 17th, early 18th century into the United States. He eventually moved from the East Coast, ended up out in the northern Illinois, southern Wisconsin area. So this is pretty much an area where he grew up, and where George did, being a member of this family. His father was fairly successful, especially following the Chicago fire of 1871. One of the things he noticed was that when they started reconstruction, of course, a lot of these buildings, and this was what, as the buildings, they weren't getting real tall, but 3, 4, 5 stories, elevators became a very common method to move between floors. And so he was involved in designing and building and installing elevators into a lot of the new Chicago buildings. So he did quite well for himself, and that provided the resources that he and his wife was able to provide for their children. Subsequently, it wasn't the fact that George was necessarily raised with a silver spoon in his mouth, but the family certainly had resources to support the education of all the family members, but particularly George in some respects. In their Kenwood home, there were a number of things that happened. George, when he was probably becoming a teenager during his high school years, he actually built a shop and a laboratory, had a small microscope, became enamored with the optics associated with the microscope, which I'm sure is the basis for some of his interests with respect to optics and telescopes. And he built his first telescope when he was 14, like a lot of amateurs and budding professionals probably did at the time. And it came to the point where his father supplied, and I think it was a 12-inch Clark refractor. It was a used refractor, and actually mounted it somewhere in their home near the top of the roof of the family house, and it was pretty substantial. So this is just an example of the resources that George had available to him. This shop that he built in the family home and put together, and I'm sure his father was involved with it. One of his brothers, I think, was also involved. But I mean, they had a wood lathe, eventually had a metal lathe. They were doing quite a bit of work in this thing. So from a technical or mechanical standpoint, this is where George gained a lot of experience. And later on, coupled with his education, he did similar things. So it wasn't just a matter of education in the sciences, but also into some of the I'll refer to it as shop. That's what it was when I went to high school. You had auto shop, you had drafting, mechanical drawing, things of this nature, but where it was actually hands-on. And so you had an opportunity to actually put hands-on and build, repair, and take apart some of these things. And I'm sure that's where he gained a good part of his experience. He was an avid reader with strong attraction to astrophysics, of course, and it was a relatively new field when he was growing up. This would have been roughly, I'm thinking the mid 1880s to late 1880s. So we're closing in on the end of the 19th century. But he read William Huggins, Norman Lockyer, and Ernest Rutherford. Pastimes, he was a typical boy of the age at that time: fishing, boating, swimming, skating, tennis, cycling. He was an avid participant in all those sports. He was an ardent reader of Jules Verne. Not so much the science fiction, but a lot of his, I guess Verne wrote a number of adventure stories, and that's what interested him. And a couple of those stories were focused or centered in California, because after a while, he does travel to California. Of course, that's where Mount Wilson is. He spent summers in Madison, Connecticut, where his grandmother's house is, where he met Evelina Conklin. Of course, that would be his future wife. And I think, when I was researching, excuse me, when I was researching Hale, didn't see a whole lot about any of his family life beyond that, whether or not they had children, and very little about his wife or any involvement that she might have had in his career, other than the fact I suspect she was very supportive. Education. After graduating from the Oakland Public Schools in Chicago, he continued his education at Allen Academy, studying the sciences, working at the Chicago Manual Training School, where he still was gaining experience and training and hands-on work with machinery, building things. He developed a knowledge for architecture and city planning, which is of great benefit to him later on in his life. One thing that I'll mention, because I know I'll forget later, architecture, of course, played a very important part in some of these observatories. But city planning, back when I said he was a founding member of Caltech, which is pretty much, I think, in and around the municipality of Pasadena. But he was a member of the Pasadena City Planning Commission and actually got involved, I think, in their first civic center that they constructed back in the 1920s. But anyhow, later on, at a fairly early age, he moved on to MIT at the age of 17. Even as an undergrad, he was working part-time in the Harvard College Observatory. He was that advanced. He did, graduate work both in the United States and over in Europe, but never finished a PhD degree. While an undergrad, he invented what became known as the spectroheliograph, which was probably the seminal tool or the most important tool that he used in his work. Because his main interest, his main research, as he went on through his career, was studying the spectra of the sun and various aspects of it, whether it was sunspots, the corona, the photosphere, and a lot of different things in detail, looking at different wavelengths. And of course, so he developed this instrument to conduct that type of research, and it was picked up, I think, coincidentally or almost collaterally, when he developed the spectroheliograph, and I can't remember the name. It was also being developed over in Europe, and almost at the exact same time, very similar models, similar in construction and design. And of course, that aided his discovery of solar vortices or sunspots. This was a large amount of the research that he focused on at the time. Some of the works, of course, originally when he finished his education, he started off in the Kenwood Astrophysical Observatory, which was pretty much funded by his father. He became a professor of astrophysics at Beloit College. I think this is probably the time when he might have done the most teaching, because later on, his assignments at some of the other institutions sort of removed him from teaching. Not that he wanted to be, but he certainly threw himself into other aspects of his particular discipline. He became an associate, then full professor at the University of Chicago, but ostensibly here again, not teaching so much, but solely to plan the observatory, the expansion, and the major installations at Williams Bay, Wisconsin, the Yerkes Observatory. Charles T. Yerkes was the principal benefactor that supplied the funding for this observatory. So just like most, observatories or places of science, names on buildings, names on equipment, it's primarily those of the people that supply the funding. One of the things that Hale started, and even after conferring with European colleagues, and they were very supportive of his efforts, but he was one of the principals in starting the Astronomy and Astrophysics publication journal. Later, it became the Astrophysical Journal in 1895. But along with, like I mentioned, he had a very collegial approach to his discipline. This was one aspect of it. He published very often and quite frequently and documented a lot of his research. Using the spectroheliograph, he discovered that sunspots were magnetic. This was a major discovery by him in 1908. So this would have been, at the time, I think he was still, might have been at the University of Chicago, but he's about to depart for California very shortly. There's a Hale-Nicholson law pertaining to solar magnetic polarity that was developed jointly with Nicholson in 1919. That was one of his legacies.
So
some of the research.
today,
Go ahead.
Today, the Astrophysical Journal is considered one of the most prominent journals that a researcher can get their work published in for astronomy and astrophysics and cosmology. So it is a very important legacy to the overall astronomy community.
Yeah. Go ahead, Doug.
When he was working at Harvard,
Not at Harvard. That was
Harvard
he went
College
attended.
Observatory.
Yeah, okay, you're right. Okay, he was working part-time there as a researcher, I think.
Would you know if he had any if he worked with or had any correspondence with Edward Pickering?
I would say yes, but I can't definitively say that.
Okay.
I would just say yes by virtue of the fact of the type of person that Hale was. I
Okay.
mean, and I might very well have run across that name. I wouldn't bet a paycheck on it, but I would say it's almost assuredly likely.
Okay.
Because one of the things that Hale prided himself in was not so much working with people, but communicating with them, talking to them, talking about the work, spreading the word. He was not one of those individuals that would take his research and hold it close to the vest. You know, I'm sure he was concerned about publishing original material, but for the most part, I would suspect that he would probably publish early rather than have to hold something in and not be able to talk to someone about it. But as far as meeting Pickering, I'm almost assured that he did. What was Pickering's what was his primary background where they might have interfaced? You said Harvard College at MIT?
Pickering was the
Harvard
director.
College Observatory.
Okay.
Pickering was doing the research on stellar classifications and so forth, and he was the one who had all the girls working for him as the computers, and that's where Levitt and all those other girls came out of.
Does that match up with the timeline? Because when he was 17,
the timeline
1885.
The timeline is just about right.
Okay.
That would have been when Pickering was there.
Okay. Interesting. Yeah. But, and Connor, when you mentioned the Astrophysical Journal, I mean, I know it takes a while for, you know, some of these publications, even the ones that have the strongest reputations, but I would imagine shortly after it became the Astrophysical Journal that they had an editorial board set up. They had peer review set up for, validating a lot of the work.
Yes, they definitely did.
Yeah. Okay, so continuing on, especially with this, you see here's a picture over here of Hale working with the spectroheliograph, and this was at Mount Wilson. There's an 18-meter spectroheliograph, which is pretty interesting. There were a number of different designs. You know, this device would actually sit, and if I understand it correctly, you had telescopes pointed at the sun. Some of them were on towers, but basically taking the image, and in some cases, actually taking the image out of the back of the telescope, sending it vertically downwards and actually below ground to knock it off mirrors down there. And one of the principal concerns at the time, since they didn't have a lot of gas transfer cooling, was to, one of the biggest concerns was trying to cool the mirrors that were involved in solar astronomy. And so one method to do that outside of using fans was to take and put it underground and use that to help dissipate some of the heat. But anyhow, some of these devices, I guess, are rather large in size. But anyhow, this is a picture of him using essentially his device at Mount Wilson back in 1908. As far as principal ambitions and the type of work that Hale was looking at, there's two here. The first two he pretty much was able to accomplish. Continued development of the spectroheliograph, learned the nature of flocculi, should be flocculi and terrestrial effects. He was one of the first to discover the activity, some of this activity on the sun, especially when there were, at the time, I don't think they were called mass ejections, but some of these ejections, and he was able to associate that with some terrestrial effects, probably radio interference on the Earth. And so he was one of the first to identify that. And then he also wanted to study the spectra of various other solar phenomena, especially sunspots in the chromosphere. That he did. A lot of different wavelengths, primarily, of course, looking at hydrogen alpha, hydrogen sigma. But this third one, investigate the stellar evolution and other bright stars, he really never got that much into. I'm sure he did some research in that area, but his principal focus were on these first two ambitions, and that was probably the bulk of his work, along with development of these other telescopes and observatories. One of the things, I had a little bit of a problem, maybe some of you all understand this a little bit, flocculus, flocculi, which are basically, as I understand it, are wispy clouds, or what appear to be wispy clouds on the surface of the sun, and they could be in other substances. And my understanding is generally the lighter areas are indicative of And I know I got this backwards. Lighter areas, hydrogen, darker areas, calcium, or vice versa. And I can't remember which way it goes. But, certainly these were the sort of things that Hale was looking at with respect to his own research. I'm just mentioning a few things, with respect to his legacy, some of the awards that he received and some of the legacy, he received over 19 national and international medals, a number of international awards, but a number of awards from the National Science Foundation, a lot of them from within this country. The gold medal of the Royal Astronomical Society in the UK, I would suggest, was very, very significant, very, very big. So was the Draper Medal. Of course, he has an asteroid named after him and a couple of craters on the lunar and Martian surface. And of note, what came from him was the George Ellery Hale Prize, awarded by the Solar Physics Division of the American Astronomical Society. And there's a host of others. The list, there's probably, like I say, there's at least 19 different awards. He merited earning over the length of his career. Contributions and work, probably the largest portion of Hale's development of observatory is Mount Wilson. Basically, he arrived on scene when there was just a foot trail up to the top of the mountain. A lot of the funding, and you can see there's a picture here, and it's him with Andrew Carnegie. The Carnegie Institution provided a lot of funding for Mount Wilson, and Hale very much, he probably invited Carnegie up there, and I'm sure he met with him a number of times personally. That's the way he preferred to do business. But Carnegie provided significant funds for the development of Mount Wilson and the initial telescopes that went up there. This started in 1904 when it was just basically a mountaintop. Some of the stories you read about the 40-inch hauling that thing up basically on, I'll call it a truck, but they use donkeys. They use donkeys to assist the truck getting up these hills. Basically, all they had was a very narrow two-track, probably more so, barely adequate footpath, but getting up and down this mountain to haul some of this gear. And of course, when he got into the larger scopes, the 60-inch, it was the way up and down wasn't that great still. So. Over 450 titles published. He was a very prolific publisher of his work. Like I say, and his research, his notes are available in libraries that he was associated with. Unfortunately, one of the things that Hale had to live with, and a lot of this was because of how much he pushed himself, because there were both physical and psychological problems that he had to deal with, especially just probably about the time that Mount Wilson kicked off. There were certain aspects. He liked being out in California. He liked being out in the mountain air. But developing this observatory put a lot of stress and strain on him, both physically and emotionally. So he had to deal with neurological and psychological problems, including insomnia, headaches, and depression. How much of that was treated, I don't know. I mean, it was well known. There was no secret about it. So I would suspect some of it was treated. There were times he would, he was aware of it, but he would take breaks from work. And for instance, one of his European trips, that was one method by which he coped and got away from work a little bit and tried to reduce the stresses in his life. But eventually it was something that probably hastened hastened the end of his life. I mean, he made it, 70 years, which is not, all that short. But certainly conditions forced him to resign as the Mount Wilson director. And this was in 1923. He still continued to do research. He still continued to work. But the last 4 years of his life, probably from about 1934, I think he was getting to the point where he may have been incapacitated and probably didn't do very much at all, and finally succumbed to some of the medical and psychological issues he was dealing with in February of 1938. One thing I wanted to do, and I'll just give you a minute to read this. This was I talked about one of the publications. You'll see it in my reference list, but essentially, it's about, I keep thinking about 20 pages, which isn't all that bad. It's out of the, like I say, the National Academy of Sciences, their autumn 1939 meeting, where they presented a biographical memoir that was put together by a name of a gentleman. His last name was Adams, and I can't remember if he was a scientist or what his association might have been. But this pretty much encapsulates probably, Hale's work ethic, and how he dealt with people throughout his life. He was viewed as a rather humble individual. Unlike some prominent researchers and scientists, it wasn't just about him, but he always pointed to being able to work with others and the fact that others were just as responsible for some of his accomplishments. Hope you had time enough to read that. And you'll see this, the third reference, if you ever get a chance to take a look at it, it will come up in a Google search if you just do a search by his name. But it was, the biographical memoirs. I've looked at a number of these. I think they're particularly good because they both capture the flavor of what they did in their career, but also a little bit about some of the things they had to deal with in their lives. And, like I say, truly, I believe the stresses associated with putting Mount Wilson, and I mean, Hale was a kind of individual, he was all for that. He was going to work himself to death to develop that observatory and the telescopes that were up there. That was just he did the same thing with his research. He put a lot of effort, a lot of time, maybe too much time. Didn't take enough time to get away from work or enjoy life a little bit more. And that's my guess, but I think it would have gone a little bit longer, might have produced a little bit more. Not that his record of production is anything less than probably fantastic or stupendous in and of itself. And as usual, thank you. Any questions?
One comment I would make is that the solar telescope that they were using bears an awful lot of resemblance to the solar scope now up on Kitt Peak, the Macmillan.
Is that the snow scope you're talking about? I don't know. There was a telescope that they actually had up in Wisconsin, I think at Yerkes, that was moved out to Mount Wilson, and I keep remembering something about 100-inch solar.
No, the Kitt Peak solar telescope
McMath
here in
Pierce.
Tucson.
That's the McMath Pierce.
Oh, okay.
Yeah, there were two solar towers built at Mount Wilson, and the principle was basically the same as the one that's on top of Kitt Peak.
Okay.
The big tower is for the long focal length, and it's to keep the air cool in that tube.
Right.
Because the solar rays coming down from the mirror, there's a flat mirror, celestat, I guess is what it's called, on top of
Yes.
the one in Kitt Peak, and that's the one that reflects the light down the tube.
Oh,
They
okay.
did the same thing at Mount Wilson. They had a celestat on tap and directed the sunlight down the tube. That sunlight would heat the air up inside the tube. So they made the tube very long. The idea is that the tube doesn't get quite so hot.
Yeah. The tube up there was also refrigerated, and they had.
Yes, that's right. They had a cooling system
that
in
tube,
those tubes.
that angular section is about 500 feet long. So the three main mirrors are up on top of that one tower, and that's 100 feet up. And then the angular part goes down like 200 feet where it hits the mountain.
Yeah.
Then it goes down another 300 feet where the final one of the other mirrors are. So
Right. Now the ones up Mount Wilson were not quite that large, but it was the same principle.
Right. Yes. Yep.
Yeah, and I think one of the reasons, of course, Mount Wilson was selected, and Hale had this 100-foot thing that he had in Wisconsin, but moving it out to Mount Wilson, since they didn't have the cooling apparatus like they do today, at least putting it up at altitude. I'm trying to remember some number bandied about, but it would have operated, of course, significantly cooler than if it was down at sea level.
Also, the air was a lot cleaner and
Yeah.
the
Yeah,
sky.
I think that was the issue. I mean, face it, during the winter, it'd be plenty cool for solar observing up in Wisconsin.
Yeah, whereas out in California in the 1920s, it was or early 1900s, it was a lot more ideal before the basin really started to
Yeah.
populate. Of course, if you're doing solar, you're not going to be affected so much, but of course,
No.
the other observatories down there.
There's-
Anything else?
There's another really good book that you can reference if you like. It's called Explorer of the Universe, a biography of George Ellery Hale. It was written in 1994 by a Helen Wright.
Yeah, I ran across that one. Yes.
Yeah, that's a very extensive biography of his.
Have you read it?
I'm about a quarter of the way through it right now.
Okay.
It's got a lot of personal information in it too, so it's kind of interesting.
Does that pretty much dovetail with what I covered, Phil? Or
Yeah, pretty much. There's a
Okay.
lot of details in this, of course, but
yeah,
and I think he was very heavily involved with the 200-inch Hale too, and I think that was part of what brought him down too, trying to get that mirror built and everything, and I think that put lots of stress on him too there at the end when he had his little chip on his shoulder, is what he referred
okay.
to his
Construction of the 200-inch was after his death, but he was
Planning.
very heavily involved in obtaining the funding and everything else to get that project started,
Yes.
which is why they named that telescope after him.
Thank you very
Very
much.
good.
It's like he'd build one big telescope and then he'd go and set up another observatory and build big telescopes, and then he'd go to another place and want a big telescope, and no wonder he went a little crazy.
Thank you very much, Pete.
Thank you.
And with that, I'm going to go ahead and end the recording for the evening. Thank you all for joining us. We'll see you next month. I do know at least one presentation ahead. Next month, Stephen Ferris will be presenting on eyepieces. It was a presentation that was given about 5.5 years ago, but we haven't had it recorded since we had Zoom. So working on getting that one recorded. And you might also learn a couple of things. I don't know if Stephen will be updating it with some newer content. But that'll be the main topic for next month's meeting. So look forward to that. If you are looking to shop for eyepieces or looking for Christmas gift ideas, you'll actually be able to know what you're shopping for this time.
Okay.
That's a good idea.
Hey, Connor, I don't know if I ever gave a presentation on the sun.
Let me check. I have the spreadsheet open.
If not, I can do that. Because the reason I thought about that was Pete was talking about flocculus or whatever it is. And it's like, yeah, okay.
I know you've done some on the solar life cycle with like you had your astronomy and the onion presentation.
Oh yeah, that's
there was that one
on evolution of stars.
Yeah, but I don't think we've done one specifically on the sun in the record that I have.
Why don't you sign me up for that?
Do
and I can do it in December.
So we're doing the sun and eyepieces in December?
Unless you want me to go back and do it in January if you've got another astronomer you want to do.
I'll go ahead and put you down. I have final exams that week, so I'm certainly not going to be able to do anything.
Oh, okay.
Hey, Connor,
Mm-hmm.
what's your projected graduation date?
Next winter.
Next winter, as in December? Next December?
Yes, next December.
Okay, because come January 1, you aren't going to be able to use this excuse anymore, you know.
Oh, I already have some presentation ideas for January.
Yeah, I know. I'm just kidding you, man.
Believe me, I very much want to be finished with
Tampa tomorrow night.
I'll be going to catch tomorrow night.
Who's going to be out of Tampa tomorrow night?
Jim Knoll said he's got a paid star party out at Tampa on Saturday.
Who does?
Oh, was it Jim or Bernie? I got an email.
It would probably be Bernie because Jim's at CAC the whole weekend.
Right, right. It must have been
Yeah.
Bernie. So there's a paid star party out at Timpa Saturday.
There
And-
is?
Yeah, and in fact, he